and you all know how to add layers, right? You have this exercise B folder. So what I added here is this HQ is like the HOCO is like the contour lines, the relief. Then I added the sea, the lakes, and the commune. So just so that you see, like, this is Uvik, the commune, Anshelsvik. But of course, it doesn't include the sea. The sea is like here. So now I have the coast. And this is more or less how it looks like if you zoom in Google Maps. And you have lakes as well. So you have all these lakes. And we also have the height curves. It's a bit messy, but if you zoom in, you see that you get all these different curves here, right? And every time that you pass one of those, you're going like 50 meters, 25 meters up or down. So right here is very high, right here it gets lower. So if you read in the description for the exercise, it talks that there are two lakes, and they have the ID numbers of the lakes. Who has the exercise description or has looked at it? The one that I uploaded yesterday. Okay, well you get it later. It's on the folder already. But let me turn off the elevation curves. So this is the layer for the lakes, right? This is only the lakes. As we usually do the attributes table, you can look for the IDs. So far, everyone has done that before and knows how to do that. Is it right? Okay. So here in the FID part is the feature ID. So in the description for the exercise, it said 512 and 495, right? So you can just look for them here. 512, here you go. And then 475, here we have. Oh wait, no, this and this. So, these are here. Here they are. You can see that you got highlighted. It's actually these two guys here, these two lakes. So you can really easily, you can find it. And what happened to the lake as in the exercise? It happened that it flooded all around up to the next height curve. So if we show the height curve again, you can see like the lakes and you have the height curve, and the water came all the way to the height curve. So, and we know that in this area there will be lots of houses, roads, and lots of different things that are underwater. So what do we want to do here? We want to find out like a way to create a feature in the map that represents this area that has been flooded, right? Why? Because if we have this feature in the map, in the ArcGIS, then we can select the houses in the house layer that have been affected. We can select the part of the road that has been affected, so on and so forth. Let me show you something here so that you get a better picture of what I mean. So let's see, we have this here. You see all these dots are the places where people live, right? Each of these dots is a 100 square meter dot with some houses, and some people are living there. So if we come here to the attributes table, we're going to see like BEF, that's befolkning. So each of these dots has a coordinate, and then a number of people who are living there. And as you may see from the map, right? If the water comes to this curve here, there'll be some of these dots that are going to be under the water, and then they're going to be flooded. So one of the things that we're going to be doing, one of the many things, is going to be to find out how many of those people are. But for that, we need to have this area that's flooded. We need to create that part. That's one of the tools that we are going to, the new tools that are being introduced in this, that are going to be introduced in this lecture. It's how to create a new feature, to create a new layer that represents that. So we've been creating new features for a while now. Do you remember when you had the dots with the cities, and you created all those circles around the cities, the buffer zone? You created a new feature there. So what was the rationale there, right? The rationale there is that you have a dot, and then you created something around it like this, right? That was the rationale. In this case, it's sort of the opposite. You have this thing here, like this curves going around, right? And you want to close them so that you can see what is inside. That's a bit of how we're going to do that. So far, so good? Yeah. Okay. So we got this, we have a map there, and let me just turn the dots off so that we can focus on what we want to do. Now that we know which are the two lakes that have been flooded, right? And we know which is the curve that we're talking about, right? That first curve around there, the first 50 meters. We can go and select the, first we clear the selection so that we, then we select the curve here. You can select it like this. Say the curve is selected there. But it is not a very neat enclosure around it. It's not a very neat polygon because there's a gap here, right? So we want to create one that's neat and just goes around the lakes. We do like this, and this actually is very useful. Is that you can search things. You have search here, right? You can type type that feature from polygon. That's what we want to go. So you're gonna come here. You're gonna type feature from polygon. Feature to polygon. Sorry, I typed the name. Feature to polygon, and if type gonna get this one on top. What does it do? We have the layer that has all the curves, right? And each curve is a feature inside that layer. What you want to do is that some of these features are not polygons. They're like, it has a gap that I showed you, for example. And you want to close that and make it into a nice polygon, a neat one that's like closed and all. So we have input features, and we have our height curve. There's a HOCO layer already there, and we have the piece of the layer that we want to use selected already. I already selected that part that's bright blue that I clicked on with the selector tool. We just input it here, right? HOCO. But then we have this funny thing called tolerance. What is a tolerance then? As I showed, there's this gap here, right? So we want to tell the computer how far the computer should look for the next part of the polygon to close the gap. If we say that, if we give it a tolerance too far, then maybe it will include things that are really farther away that are not part of it. If you give it a tolerance that's too low, it won't find the part that closes the gap that's here. So, because it takes a lot of time to find out what's the optimal value, I'll give you the value here. We can input 125 meters, and that would work. Or you could try many, many different times until you find it, but that would just be frustrating. I don't want you to be doing that. So, when you do this, you see that a polygon closes that. Now I have a polygon around there. And that's the area that's flooded. Do you guys all understand the sequence? Do you guys get the logic behind what we're doing? If it's not clear, please ask. Because I'm not going to be here next week, it's going to be Martin. So here is going to be already doing all the parts of the exercise. All right? Okay. So we can turn off the code. And let's just change it so that we have a, yeah, this is nice, potential flood. Okay. So this is how it will look like. And we have a polygon, the lakes are just for aesthetics. You don't really need the lakes anymore. You can even turn the lakes off. Right? You can turn the lakes off. And you get the houses. And you can see that some houses intersect that, some houses don't intersect it. And then you're going to do the usual stuff that you did in the other exercise with selecting by location, and then summarizing or getting the statistics. And that, I think, I don't need to show again because you guys have already done in the other one. But sometimes you would want to get a piece of another layer. And I'm going to show you the population one, because population one is not one of those that you're going to need that. But say if you have roads, right? These are the roads. And you see that parts of the roads are going to be affected by the flood, right? Sometimes you want to create a layer that has only the parts of the roads that have been flooded. In that case, it's almost as if you wanted to use this polygon that you created as a cookie cutter. You know, like when you have a cookie dough and have all those cookie cutters that like shape like stars and like whatever, like hearts and all that, and then you just come and you press it against the dough and it cuts. You can do that, something called clip. So you can actually clip that part of the layer of the roads so that it only has the part you want. Again, geoprocessing, clip, and then input features. You're going to have here, let's say the roads, and then you're going to clip using the polygon, and yeah. So if you look at this, see, you take off the polygon. Only the roads that have been affected are there in that one. Now, maybe for the roads, in this case it's very little, maybe for this particular scenario, you could just look at that, just look at that. But there would be like, you might want to look at how much of agricultural land or how much of swamp has been flooded, or in the other scenarios you have the fire, so you have like how much of agricultural land is under the fire. And then this clipping thing becomes useful because you throw away everything that's not under the fire, everything that's not flooded, and then you get this layer that has only the part affected. And then you can do the statistics, the summaries, and everything on that. Because, say, if you would just get this layer here, right? And the attribute table have like length of roads, right? You have all these different roads and lots of length there. But this is for every single road that there is in the entire municipality of Örnsköldsvik. A lot of these, majority of that is not under the flooded area. But now that you flipped it, you can look exactly at how many meters of road are flooded. And maybe you want to calculate that. Right, is that clear? Why you would want to do that? No. Huh?